Alright, in the last chapter, we have done inquiring the assembly. If no problem, we can continue. If not, we need to edit the assembly to make it function as well. So in the next chapter, I'm going to introduce you how to manage and edit assembly, and also some related tools. Okay, in the first place, I'd like to show you how to hide the component. It's easy, and we can find the command once we right-click on the component in the assembly tree or graphic area. And please be noted that the corresponding constraints will turn blue once it's hidden. And another operation is suppress. It appears to be the same as the hide. But for suppress, it actually will remove the component temporarily. And the related constraints will turn red. And sometimes we need to make several copies of a component. In ZW3D, there is several ways to achieve this purpose. Ctrl+C is one of them. Besides that, you can actually press Shift and Alt key. Meanwhile, hold and drag the component to make copies. What's more, we can copy component with constraints. Here I made a GIF for the steps. Okay, and sometimes we need to make an unlinked replica out of the component or assembly. To be specific, when the parent object changed, the replica will not be changed. In other words, it's independent. In ZW3D, we have an exclusive command called make independent copy. With it, we can do it quickly, and the 2D sheet or CAM plan can also be copied. Okay, now let's move over to ZW3D to show you more details. Okay, so first I'd like to show you how to blank and unblank the component. It's very easy. You can select component in the graphic area or just from the assembly tree. Okay, and blank it. And after you blank it, as you can see, the constraints will be turned blue. Okay, so if you unblank it, it will turn to the normal color as well. Okay, and for suppress, actually it's a little bit different. Now let's try it. Suppress it. As you can see, just like the blank command, the component is disappear in the graphic area. But actually it's different. You can see all the constraints are filled temporarily. Okay, so it's like you remove this component temporarily. Okay, so we can now unsuppress it. Okay, now you can see everything going well. Okay, this is about the blank and the suppress. Okay, next one is how to copy the component. Okay, we have actually 3 ways to do it. First way is we can just click on it and Ctrl+C and Ctrl+V. Here you can see we have one more, right? Okay. And another way is we can press Alt and the Shift key in the keyboard. Meanwhile, we drag it 1, 2, 3, 4 as you like. Okay, this is the second way. And the last way is copy with constraints. Okay, now we delete the useless copies. Okay, here we use this bolt as an example. For example, we want to add the other 3 bolts to the 3 holes. Meanwhile, we want to keep the constraints this bolt already have. Okay, now let's see how to do it. Right click on it and copy with constraints. Here you can see for this bolt it has 2 constraints, coincident with the planar face and the constrict with the hole. Okay, so all we need to do is select the planar face again and then select the cylinder face. Okay, now you can see it has been added. And you can check it here, coincident and the concentric. Okay, you can click OK to get the result. Actually, okay, and we can do it one more time. Copy with constraints. planar face and cylindrical face. Then we can add one more time. Okay, now we can we add 2 of the bolts. Click OK to get the result. And here you can see for this bolt it has all the constraints. Okay, so you do not need to add it one more time. Okay. And sometimes we need to make an unlinked replica out of the component or assembly. So to be specific, when the parent component changed, the replica will not be changed. In other way, it is independent. Okay, in ZW3D, we also have an exclusive command to do it, which is make independent copy. Now let's see how to use it. For example, for this one, okay, we can right-click on the tree, slider base, and here you can see make independent copy. Then you need to give it a new name. We can add prefix or suffix to it. And if it's a sub-assembly, we can include all the children components in. And also if you have some 2D shade for this component or sub-assembly, you can also link it. Okay. Here we use a new name, 01. Okay. Now you can see actually we have a new component. And there's no link for the new component and the original component. Okay. Okay, next command is change. It's easy to understand. We can replace a component with one another. But please note that in most cases, you may need to redo the constraints. Next one is switch part configs. As you already know, we can make multi-part configurations based on different sizes or attributes. So in the assembly, we can choose the most suitable one. And also you can show the config name in the assembly tree if you want. And next, I'd like to introduce how to make a component to be virtual or envelope. For virtual component, it's saved internally in the assembly file, no independent file. It's more convenient to edit, rename, and file management. For component envelope, it's a special component. You can use envelope as a reference, which can help you to envision how to size and position the functional components. They are ignored in BOM and math properties. Okay, now let's move over to ZW3D to show you more details. Okay, first let me show you how to switch part configs. Okay, we still take the slider base as an example. Because we already made some part configurations for this part, so we can switch it to the one you like. We can right click on it, and the configuration here, you can see we have different configurations. For example, we can change it to width equals 20. Okay, now you can see this is the result. And the next command is change. We can totally change this component to a completely different one. Okay, right click on it, and we change component. Okay, we choose the new one, which is slider base new. Okay, click OK to get the result. And we can region to get the final result. Okay, this is the mirrored one. Okay. And the next I'll show you how to make the virtual component and the component envelope. Okay, first how to make a component virtual. So as you know, every component has its file in the Windows Explorer, right? We can right click, rename file to see the file name. Actually, for the rename file command, I'm gonna to cover it later, but no problem. We can getting started to use it right now. Okay, here you can see for the slider base new, actually its corresponding file is slider base new .z3prt, right? Okay, now we make it virtual. Right click, make virtual, and it will show you a prompt. Making a component virtual will lose the link to the external file. Continue, we click yes. Here you can see there will be a little V letter in front of the component name. Okay, here we can check again, rename, And now you can see for the slider base new, it only belongs to the ejector.z3asm file, no independent file, right? Okay, this is the result. And if we make it virtual, it has some advantages. For example, we can make it more convenient to edit, rename, and to do the file management. Okay. And the next command, I'd like to show you the envelope. Okay. So here we insert another component, reference box. Okay. So for this component, we just mean to envision how to size and position the functional component. So they are ignored in the BOM and also in the mass property calculation. So how to make it envelope? So let me show you. Just right click on it and make envelope. Okay, here you can see after you make it envelope, the icon will be changed. You can see a little rectangle surrounded the icon. Okay, and also you can see the color will turn to like light green, right? Okay, and also you can change the color in the configuration. Color, you can see envelope, you can change it. Okay, and now we can go to the 2D sheet to see the difference for the envelope. Default, okay. But here we need to display the envelope. Show envelope here. Okay. Now you can see the envelope component will be in the dotted line. Okay. And also you can change the style in the style manager. Lines and envelope here. You can change it. Okay. Okay, next I would like to show you how to edit component and regenerate in the assembly. For edit, you can both do in-place edit or open it directly and edit. For both ways, after the part is changed, we need to regen it in the assembly. So in this page, let's talk about regeneration. In assembly level, we have 3 regeneration commands, which are regen assembly, regen outdated components, and regen all components. For the first one, regen assembly, it will only refresh the constraint status. For regen outdated or all components, that means regenerate the modern history of the components. Meanwhile, the constraint status will be refreshed simultaneously. Okay, now let's move over to ZW3D to show you more details. Okay, next I'll show you how to edit and regenerate the assembly. Okay, for example, now we want to edit the slider base component. We have 2 ways. First way is we can just in-place edit it, which means we can just double click it. Okay, now you can see the unrelative component will turn to like transparent. Okay, here this is the modeling tree of this component. Sorry, it's for Chinese, but no problem. We can continue, and we can add more features here, like we can add a chamfer. Okay, now we can go back, and also we have 2 ways to go back. First way is we can just double click on the assembly. The second way is we use the exit icon here. Okay, now you can see after we return to the assembly level, you can see there will be outdated for the assembly. So all we need to do is regen outdated component. And another way is you can just open it. For example, we can open this one. Then we can change something. For example, the radius of the fillet. You can just click it and save it. Okay, also you can see outdated. We just regen outdated component. And sometimes if you want to make sure every component is in the right position, you can just right click and regen all components. Okay. But normally we just regen the outdated component. because if you region all, it will be time consuming. Okay, sometimes we need to adjust assembly structure. Two typical cases are group and dissolve subassembly. For group subassembly, it will create a subassembly with several components. And of course, you can add more components in it later on. For dissolve subassembly, on the contrary, it will delete the subassembly and move the inside components from lower level to upper level. For subassembly, as you know, it can be seen as an entirety in the parent assembly, so we cannot verify the components' movements inside it. In other words, it's rigid. So if we want to do it, we need to make it flexible. Okay, now let's move over to ZW3D to check out more details. Okay, next I'll show you how to adjust the assembly structure. Okay. So first is how to group subassembly. For example, we want to make a subassembly out of these three components. So we just select them all and right click, group as subassembly. Okay, we give it a name like moving part. Okay. And now you can see it's done. And of course, you can drag more component in, like this one, you can drag it in. Okay. And also you can drag it out again. Okay, we region it. And after the subassembly is created, actually it's rigid, which means it's an entirety. So if we move it, like if we want to verify the internal movement, actually we cannot do it. You can see it's like fixed. Okay, so if we want to make it possible, we can just make it like flexible. Okay, right click on it and we make it flexible. Okay, after that, we can verify the internal movements freely. Okay, here you can see it's back to normal. Okay, so this is about the flexible subassembly. And if you want to make it rigid, you just right click and make it rigid. Okay, and next I'll show you how to dissolve the subassembly. Actually, it's quite easy. We just right click on it and we can dissolve assembly. Okay, we region it. Okay. Okay, next, I'd like to show you something about transformation. It's relatively easy, like a move, copy, and a pattern, similar to the part level. But for mirror, it's a little bit complicated. To be specific, you can choose to do the position mirror or true mirror. So what's the difference? Let me explain. For position mirror, it will only move the component about the plane with flipped orientations. It will not create a new instance. So for some self-symmetric component, this will be a good choice. But for true mirror, it will create opposite hand version. So there will be a new instance created. It's always used for a symmetric component. Now let's move over to ZW3D to show you more details concerning transformation. Okay, the first one is move and copy. Actually, it's in the same command, move. Okay, and also you can find it in the right menu click. Here, move. Okay, and if you want to copy it, you can just check on the copy. Okay, then you can move it by the handle or by many other ways. Okay, here we can use the handle. Okay, so this is about the move and the copy. It's easy to understand. Okay, and the next one is about the pattern. Okay, pattern, and here you can see there are 6 pattern methods here. Actually, it's similar to the pattern in the shape tab. So we are not going to introduce them one by one. Just the first one as an example. Okay, the first one is linear. Okay, now we choose the base as the first, and then we choose the direction. We can choose the X. Okay, and the number and the space. For example, we make the number 3 and the space as 60. Okay, and here you can see there are some options. First one is instanced as component. You can check it and check the result here. Now you can see actually there's no pattern feature here, just the two more sliders here. Okay, and if we move the original one, the other two will not be moved simultaneously. Okay, now we erase these two. Okay, now let's check more about the pattern. Pattern, okay, and direction X, and we uncheck this one, and we inherit the constraints. Here you can see there will be a pattern feature here. So if you move the original one, you can see the other two will also be moved. Okay, this is about the inherit constraints. And the last one is easy to understand, whether you want to inherit the attribute from the parent. Okay. Okay, this is about move, copy, and the pattern. And the next one is mirror. Okay, we also erase this one. Okay, now let's see the mirror. For mirror, we have two ways to do the mirror. The first one is position mirror, and the second one is true mirror, which also duplicate. And you can see the little icon. It will create a new file here. Okay. So for symmetric part, actually we can use the copy. Okay, which is just position mirror. For example, for this component, we choose it and choose the plant mirror. Okay, and here you can see you can preview the result. And before you do the position mirror, actually you can choose to flap the component about a certain datum plane. And for the datum plane, you can choose the datum plane located on the center of the bounding box here, XZ, YZ, and here you can see the preview of the datum plane, XY. And also you can choose your customized plan here. Okay. And also you can choose the datum plane of the center of mass initial coordinate system, which is XC, YC, YZ, YC, ZC, and IC, YC. And the result will be different. And actually you can see there are more settings. For example, the first one, whether you want to erase the source geometry. Okay, normally we do not check it. And the second one is similar to the pattern, whether you want to create a mirror feature or not. And the next one is as a whole to mirror. So if you select multiple components, so whether you want to make them a whole to mirror or mirror them separately. Okay. And the last one is also similar to the pattern, if you want to inherit the attribute from the parent component. Okay. And now we can click OK to get the result. Okay, this is the result. So this is for position mirror. And we have another case to show you the true mirror. This case is like a brick system, right? It's a sub-assembly, brick assembly. If we use the position mirror, actually we cannot get the results we want. We can try it. And the plan, YZ plan. And actually here you can see, if we see it in this angle, you can see actually it's missed the right position, right? Okay. No matter how we change the flap plan, we cannot get the result. This one is also wrong. Here you can see. Okay. So for this asymmetric component assembly, we can use the true mirror. Okay. So here you can see when we select the true mirror, the self-symmetric will be turn green. Okay. And here you can see for sub-assembly, actually we can choose some of the components to be true mirrored, and some of them to be just the position mirrored. For example, for this mounting screw, we can choose it to be position mirror, which is copy, and here we can choose to mirror it by the data plan of the center of mass initial coordinate system. Okay. Okay, this one is good. And we can click OK to get the result. Okay. And it will actually create a new assembly and the components here. If we check it, name file, here you can see there will be new file created. Right? It's not the same file. Okay. So this is about the mirror, position mirror and the true mirror. Okay, just now I have introduced something about component management, editing, and transformation. And in the last, I'd like to introduce one more important tool, which is rename assembly. As you know, we cannot just rename the component name in the Windows File Explorer, because that will cause the link between the assembly and the components get lost. So in ZW3D, we have a powerful tool to fulfill this purpose perfectly. Now let's move over to ZW3D and show you the steps to do this. Okay, now let me show you how to rename assembly. We have two entries for this command. The first one is from the Tool tab, rename file here. But for me, I'm more used to right-click on the assembly manager. Here you can get the rename file. Okay. Okay, for rename file, first step is select the components you want to rename. For example, you can single click on it, or you can press Ctrl. Okay, now we select two. Okay, and of course you can use some rules to filter out the components you want. For example, here we can search it by name. For example, like spindle. Actually, when I type SP, it will select it for me. Okay, and the next step is rename it. We can type the new name for it. For example, for this case, we can just type a new name, spindle 2. Okay, now you can see spindle 2.z3prt. And also we can rename by some rules. For example, for these two components, we can rename it. We can use the first one, use template. For example, we want to change the slider character to SL. Okay, we can see how to do it. Slider, and we change it to SL. Okay, so after we make the rule, we can click on the new file name. Okay, here you can see all the slider character will be replaced by SL. And also you can add the prefix, suffix, or even add the properties to the name of the component. Okay. And also the next step is we can rename the related objects. For example, the 2D shades or the CAM plan. Okay. And now we are ready to go. We can just apply or click OK directly. Now you can see the name is changed. And also we can check the Windows Explorer. So here you can see spindle 2 and SL base SL. Okay, you can see all the name has been changed.